Hello there, I'm Sharir from Roborear. In this video, we are gonna learn all about this breadboard. We are gonna make four mini projects about how to connect an LED with a resistor and make a series circuit. And the project 4, we are gonna learn about parallel connection of resistors. In the project 3, we are gonna learn about how to make a variable resistor using a potentiometer and how to make it as a switch. And in project 4 we are gonna use a sound sensor module to make a very simple project, and this is gonna teach us all about this breadboard. I hope you'll like this video, so let's start this video right now. So this is a breadboard. Usually breadboard comes in different sizes, but for me this is a rectangular in shape, but you can find some in square, some in shorter length, and some in one section. There are two partitions, but you may find just one. So how these holes are connected. In this section, on the top and on the bottom, you can see there is a connection, blue and red, signing plus and minus. This is the power rail. There are four power rails. This is called power rails. Plus terminal of the battery and the negative terminal of this battery is connected here usually, but you can connect in any of the pins. And you can see the holes, the number 0, 5, 10. These columns are connected in series and these rows are connected in parallel. If there is a partition, you can see, and this section is not connected with this section, and the power rails are not connected with any of this section. So let's make a simple circuit. The hello world of electronics is known in here like the very easy circuit. This is an LED, this is LED, and this is a resistor. This is actually a 325 ohms resistor. So what we are going to do, connect this LED in any of the holes in this breadboard. Let's connect in 30 and 30 and 34, and use a resistor here, like connect the resistor with the 20. So now just connect this. Now connect this battery source. This is actually a 9-volt battery. So you just connect with this row, in this row of 21, any of the hole, just connecting it here, and the other end in this line, in any of these holes. Just look at this. The LED started emitting light. So what we have just did, we connected a 9 voltage of battery with the resistor and the LED. But never connect this LED without the resistor. What happens, the LED actually will damage if you don't connect this resistor with it. So yeah, that's the hello world of electronics. So in this part of this video, what we are going to do, we are going to make a parallel circuit with resistors and LEDs. 3 resistors and 3 LEDs are connected in the parallel. First take the red LED, connect it with the breadboard. 25 and 29, pin number 25 and 29 connected with the both terminals. Then use the blue LED there, and then connect the yellow on the same holes, the same serial of holes. And then we are going to use, this is a 1760 ohms resistor, and this is a 325, and it's also 325. These resistors are both in same resistance, but it is higher. So if we use with any of these LEDs, that will be less brighter. So let's use with the red one connected, and then connect the other resistors in the circuit, and the last one with the yellow LED. We just made the parallel connection of resistor with the LEDs, and 3 resistor plus LED connected in parallel. Now we are gonna use this 9 voltage of battery in this circuit. What we will see that it will be less brighter and they will be equally brighter because each one have equal resistance. Let's see. You can see yellow and blue one has light, but the red one is not bright, not any bright. maybe so less. Just troubleshoot the thing. Yeah, it's working. But if we check only, we can't see any light from the red one, but it's actually working. Let's see. Remove the other things from the circuit, and let's use this 9 voltage of battery only in this part. See, it's working. It's working. So we can see what's happening. Let's look in the diagram. So in the diagram, we can see that we have connected the 9 voltage of battery in with this parallel circuit connection. But here the resistance of the red LED is higher. Higher resistance, less current. Maximum of the current is flowing through this portion. So they are becoming equally bright because equal amount of electricity is flowing through them. But less electricity is flowing through this path, so less brighter it is. And that's the parallel connection you can do in your breadboard. Now we are gonna learn how to use this potentiometer in our breadboard. First of all, this is a potentiometer. It has 3 terminals. If we want to use this as a variable resistor in the breadboard, what we can do, this is the variable connector pin, and this is the constant pin. If we connect it with this side and the variable pin, if we rotate this knob to the leftmost part, like counterclockwise, then the resistance of this potentiometer turns to 0. And if we turn this to right, it will just change the resistance variably. Like now it may be 2.2 kilo ohms, and then if we rotate to the top most right part, then it will be 5 kilo ohms, and this is a 5 kilo ohms potentiometer. So we will use this potentiometer as a variable resistor in our breadboard. First of all, let's make the previous connection we did. Connect the LED, then with LED connect a resistance, and I have connected 2 jumpers with my potentiometer, one to the middle and another to the left part. Now connect this jumper, now connect this middle one to the with the one side of the resistor and another just in this pin. Now we are gonna connect this potentiometer in this circuit. Let's connect the positive terminal and negative one. Let's see it's working. Yes, it's working. Never connect a potentiometer directly with this LED. Always use a resistor in between, because if you just by any chance turn this to the leftmost part, what will happen, it will become zero resistance. Zero resistance means all the voltage will flow through this LED, and it will hamper this LED. Now you can see if it is in the full potential. Now it is in zero, short circuited potentiometer connected with a resistor, and then this LED. Now it's having the full potential. Now if we turn it to the rightmost, now see the LED has become dimmer, and if we turn to the left again, it will become brighter. It's becoming brighter slowly. See, it's working. So by this way we can use a potentiometer as a variable resistor for our circuit. So we can improve or change this circuit, like we can use this potentiometer as a switch. Just changing this circuit a little bit, any of the terminal, just take this one and connect it to the opposite end of this LED, the negative terminal of this LED. Connect this and connect this positive terminal of this battery to this portion, to this pin. To this pin, and negative portion to the opposite end. Opposite. Okay, now what is happening, the potentiometer is parallel with this resistor and this LED. We can use this as a switch. If I turn this to the right, to the leftmost, let's turn it. Just see the LED will stop. radiating light. It just stopped cause there's happening a short circuit there. And again, if I just rotate clockwise, it's again radiating light. And the higher the resistor of this potentiometer gets, the brighter this LED works. Let's see why this is happening actually. So let's see what we did on our breadboard. This was the potentiometer. We have a 5 kilo ohms of potentiometer, and this is the circuit diagram of the potentiometer. For the first case, we connected the 9 voltage of battery with the potentiometer, then connected with the resistor, then with the LED. And what we did, we changed the knob in between and to the leftmost and rightmost for the potentiometer, and found on the leftmost it becomes short circuit. So the only resistance here is to 325 and the LED, so the current will just go through this path and go through the LED, and the LED will light up. If we maximize the potential to 5 kilo ohm, then the light will blink less, light will have less strength, and if we make it 0, then the LED will have full potential. For the second case, we used it as a switch. For this case, 9 volt was connected with the potentiometer parallel with the 325 resistor and the LED. For this case, if we turn the potentiometer to 0, the leftmost of the knob, then the current will have a short circuit path, and current loves short circuit. Then it will just flow through this path and won't flow through this path. So what will happen, the LED won't light up, no current will flow through the LED. But if we change the knob to not exclude 0 and anything in between the value 0, excluded 0, then what will happen, the 9 voltage to direct through the 325 or also in the potential, then current will have both paths and will flow through both of them, and the LED will blink. In this way we can use it as a switch. Like if we just turn this 0, then the light will go off, and if we turn to the right side of the potential of the knob, then it will just have electricity and the LED will work. And that's the electricity flow from through the potentiometer. So in this last part of this video of this breadboard tutorial, what we are gonna do is make a very simple project using this sound sensor module. Sound sensor module actually captures the noise and translates it into digital signals. Like if I say something here, it gets the voice and makes it a digital signal. And we will use this capacitor and buzzer, obviously 9 voltage of battery. And in this part we are gonna use these power rails. There are 4 power rails in my breadboard. In many breadboards there happens to be no power rails. It's just actually the same. This line is actually connected in series, and this line is also connected in series, but they are not connected to each other. And this is one power rail, this is another, and there are 4 power rails. So let's start make this project. This buzzer, this is the positive terminal and this is the negative, just connected to the breadboard. Maybe 50, number 50, and the next one is 47. Let's use this capacitor. Capacitor's positive terminal, the positive terminal 50 and number 47 connected. And we are gonna use this sound sensor module. There's 4 knobs there to connect with this breadboard. The battery negative, battery positive, output positive, and output negative. So let's first use the battery positive. Battery positive with the positive of the power rail. Battery negative with the negative of this power rail. And then we are connecting this output positive with the number 50 hole of our breadboard, and the output negative to the 47. Okay, it's all connected. Now just we have to use this battery to our circuit. That's connected. Battery negative, battery positive, both connected, I guess. Let's see. If I make a very high noise here, and then the buzzer will buzz. For my it's buzzing already. For my sound sensor, there is no potentiometer. You can change the sensitivity using the potentiometer, but for my case I can't actually do this, so I have to make a very high noise. Let's try this. It's actually buzzing there. So we are actually using this capacitor to make this buzz time longer. Like, it's just buzzing with a fade out noise. But if we don't use it, just disconnect this, it's just working with the duration of my noise. Like, check again. But if we use the capacitor again in parallel, we have to connect this in parallel, obviously. Okay, connected. Let's do this. It's just leaving a fade out noise cause this capacitor just stores some amount of charge, and when I stop making noise, the capacitor releases charges to the buzzer and the buzzer starts buzzing. And that's it for this project. You can use it and make fun of it. You can also connect with LED with it and make different cool items. I think you have learned some insights about how to use this breadboard. That's not all about this breadboard. We can connect microcontrollers or ultrasonic sound sensors, or we can even add motor controllers in the breadboard. We will do all this thing in this channel. Hope you like these videos, and I hope you have liked this video, and thanks for staying tuned with me in all this time, and thank you very much.